So I don't want to compound your fears about your exams, but in this episode, we're going to talk about compound interest and also compound decay. So the formula for an amount after a given amount of time would be that the amount you have is equal to the amount you started with times by a multiplier, all to the power of how many time intervals you've had. So for example, if you start with £100 and you get 10% interest, so it increases by 10% each year, and you want to do that for 3 years, you take 100, your starting value, times it by 1.1, the multiplier for a 10% increase, and do that to the power of 3. So 100 times 1.1 to the power of 3. Think about multiplier, just need to be careful. If you're doing a decrease, so say you've got a 40% decrease, that would be 0.6 your multiplier, because 100% take away 40% gives you 60%, which as a decimal is 0.6. Now, when an amount increases or decreases by a set percentage on a regular basis, this is what we call compound interest or compound decay, depending on if it's increasing or decreasing. And if the amount lost or gained changes with each interval, since the amount lost or gained is a percentage of the current amount. So every time, say you gain £100, so you've got £100, you gain a bit of interest on it over a year, you then get interest on the full amount for the following year. So it will change each time. So remember, what do we call it when the amount increases by a set percentage on a regular basis? That's what we call compound interest or compound growth. And when the amount increases or decreases by a set percentage on a regular basis, this is called compound growth or compound decay, depending on if it's increasing or decreasing. The amount that's lost or gained changes with each interval, since this amount is a percentage of the current amount. Now, in summer, the number of ants in a colony increases by 20% each day. And on the first day, there were 10,000 ants. So after 3 days, how many ants would there be? So if it increases by 20% every day, you've got to think about how much it's going to increase each of those days. So what we'd do is we'd do 10,000 starting number of ants times by the multiplier, which in this case, a 20% increase would be 1.2, and do that to the power of 3. So 10,000 times 1.2 to the power of 3 to get your answer. Now, a few key terms for you. So the compound interest is when the amount of interest in a bank account is calculated again each interval rather than using the starting amount. So depreciation is when the value of an item decreases each year as it ages. So again, there's a set percentages. The amount it increases in a bank account will vary each year because there'll be different amounts at the starting point of each year. And the same with if something is depreciating in value, it will have a different value at the beginning of each year, and therefore it will depreciate at the same percentage but a different amount. So let's have a look at an example. So Alicia has £400 in a savings account. Lucky Alicia. Each year, the amount of money in her account increases by 5%. How much money will the account have after 4 years? So what we can do is we can either say 400 times by 1.5, our multiplier for a 5% increase. That will tell us the amount after year 1 is £420. After year 2, we can say, okay, we need to take that £420, what she had at the beginning of year 2, times it by 1.05 again, 441. After year 3, we can say, okay, 441 times by 1.05 again. That would give us £463 and 5p. So lucky Alicia's just gained £63 and 5p just by putting her money in a bank account. Now we could do it that way, seems quite long-winded, or we could just do 400 times by the multiplier to the power of how many years that it is. So 400 times by 1.5 to the power of 3. To the power of 4. That will give you the same answer. Another example. This time, Alicia hasn't got quite so much cash in the bank. She's only put £100 in. But this time she gets 20% interest. So each year she will, the calculated at the beginning of the year will be worked out, and she'll get 1.2% multiplier on it. Now we know we can just do it really quickly. After 4 years, she can just do it by doing £100 times by 1.2, which is the multiplier for 20% increase, power of 4. So 100 times 1.2 is 4. That will tell us she gets £207, 36 pence. I'll be banking with her bank. So in the summer, again, we're going to think about this ant colony. If we're thinking about how many days have passed as n, we can say it's 10,000 ants times by 1.2, the 20% increase, to the power of n, the number of days. And we can put any number of days in that. We could put 5 in there. We could put 10 in there to work out how many ants there are at any time. And that would give you the answer. So for example, 10,000 to the power of 7 would give you 35,831.8 as the number of ants. So we can round that up because you can't have 0.8 of an ant, or it would be a dead ant if you did. So another question for you to think about compound growth and decay. So if a company has 10 employees and every year the amount of employees increases by 10%, what is the formula for the amount of employees after 5 years? We've got 10 as our starting value, a 10% increase every year, that's a 1.1 multiplier, and after 5 years, that would be 1.1 to the power of 5. And that is that when it comes to compound interest. Really compounded my knowledge. I hope it has yours. And that's when it comes to compound interest. It's really compounded my knowledge. I hope it's compounded yours. Good luck with everything.